All right, this time we're going to go ahead and do a delid and lap the IHS on this ProStar laptop. This is a Clevo P870 model. Jason, this is for you. The good folks over at ProStar, Wesley, Jeff, thank you. You guys have been very accommodating. One of my concerns on this laptop is that it typically runs hot. We don't have the ability to cool it like we do with a desktop. And my customer is going to be hitting this thing pretty hard. I know that we're doing some heavy-duty image editing. It's not video, it's 2D, but we're doing Z-stacking. So we're working with programs that are stacking images, and so it's both CPU intensive and GPU intensive. So we're going to use a Rocket delidding tool here, which we've used many times on the X299s. We're using Conductonaut Thermal Grizzly liquid metal, and I'm going to use this Innovation cooling. This is a graphics pad that's going to bond between the heat spreader and the CPU cooler, which is kind of different. This is a cool concept in that this is virtually indestructible and should last forever. So ultimately making a more reliable machine. That's my whole goal, is reliability on this machine. We want it all. We want performance and we want reliability. I did the initial testing on this machine, and I've run IDA 64 and Intel Extreme Tuning Utilities, stock, IDA 64, CPU only. I ran it for 5 minutes and she hit 85 degrees centigrade. I ran IDA 64 CPU and FPU, the floating point unit, and it failed it in 5 seconds. It thermal throttled almost immediately. I ran Intel Extreme Tuning Utility stress test for 5 minutes, and my maximum temperature was 91 degrees. I ran Cinebench. I got a score of 1383, 90 degrees. Blender, we did the BMW 27 in 5 minutes and 46 seconds, 90 degrees. Extreme Tuning benchmark stock, we have 2,325 points or marks, 97 degrees. This is getting way too hot. And the Intel burn test standard only did one pass, 95 degrees Celsius. So we're out. Okay. So then I undervolted this thing. I went down to, I undervolted it by 0.125 volts. And this is per core. So we've gone down and we've reduced our 85 degree temperature in IDA 64 to 80 degrees. Then we went and we did an AVX -3, and then -5, and then finally a -3 AVX with a voltage offset of 0.2 volts per core. And we were able to get IDA 64 with both CPU and FPU for a 10-minute test with a maximum of 80 degrees centigrade. So a big improvement by undervolting it and running the AVX. Now I can adjust the undervolt in the BIOS, but I can't change the AVX instruction set in the BIOS on this machine. So I've been using the Intel Extreme Tuning Utilities. I'm going to go in the BIOS and set the undervolt to 0.2. We've run every stress test that I can on this, and at a 0.2 volt undervolt, it's fine. Everything is passing with flying colors, and our benchmarks are the same. So that's a good sign. Ultimately, we're going to go ahead now and delid this thing and lap the CPU, and I'll go ahead and break it open, and then we'll compare those in addition to what we've got here. So what I'm going to do, I've gone ahead and I've already taken out the 9 screws on the bottom of this thing. And we should be able to crack this thing loose. There we go. This is a real piece of engineering. I love this box. It's got the heat sinks for up to 2 graphics cards and the CPU over here. Here's the battery. I'm going to go ahead and get busy taking this out, removing the battery and removing what I need to do to get to the CPU. And when we get back to it, I'll pull the CPU out and start it over again. I don't want to bore you with the gory details. Okay, I wanted to get a close-up of this. I've released the screws that hold on the CPU heatsink in reverse order. There's 4, 3, 2, 1. These are numbered 1, 2, 3, and 4. For assembly, you take them off in the exact reverse order. I have removed the 3 screws that secure the fan as also part of the heatsink. I'm leaving it connected on the wire there. I'm going to roll this back and take a look at the CPU. All right, it's loose. Very carefully, solid copper, and there we have it. Okay, so here's my fan, my thermal pads, my thermal grease, and there's my CPU. And we will remove the CPU and clean it and clean this up and put everything back together after we've gone ahead and lapped it. I'm going to get this up and out of the way. I'll disconnect it off the main board and move it out so we don't damage anything. But I'll get back to this once we get the CPU going. I have a couple of observations from a technical standpoint. Here's the CPU, and I can see that it's been dated, and it's got a serial number on it from probably from the good folks over at ProStar. I am not going to remove the rest of this thermal grease until I pop the heat spreader off, because it's all around right close to the board. So I'll pop that off and clean it when I do it. Everything else looks terrific. What I did notice on the cooler here is that this plate that is actually spot welded on, this copper plate that is to the heatsink that is to sit on top of the IHS, is anything but flat and straight. It has a divot in the middle. It's got some ripples on the side. It's got a band across the top where it was obviously placed in there. I ran some 1500 grit on a glass lap over the top to see my pattern. These are all my low areas in here. And this area over here is on the high side. I don't know if this is going to be a candidate for the graphite pad or not, because this is not a very thick pad. This may be a better candidate for thermal grease, because the thermal grease would have a way to fill into these low spots. I mean, I'm not going to lap this thing down to get rid of these. I don't think there's enough material on this to do that. So if I don't get the results I'm looking for with this thermal pad, we may be going back to some thermal grizzly thermal compound on that. By the way, that's just an observation I've made so far. Everything else is fine. I'm not going to switch this out with Fuji Poly. It looks great. So right now I'm going to pop the CPU open and see what we can do for the heat spreader in there. That's it. Okay, so we've got our CPU placed into our tool here. We have a triangle there. We have a triangle here. We're going to place this in very carefully. Make sure it's locked into place. This goes over the top. This has to be set all the way back. These get screwed down. It's like with anything else, if you have to force it, if you have to twist and turn it, there's something wrong. So you really search for that path of least resistance. And these are a really great little tool. This and the Debauer tool, I mean, they're a fantastic idea. It's bringing delidding into the mainstream. Okay, so now I've snugged these up. I'm going to start to screw this in. Okay, that was the pop. Out it goes. We don't want to take it past the point of release at all. This one's not as bad as the 2066 that has all these components inside of it. All right, take the top off. Okay, and there we are. And that's it. That was pretty painless. There's not a lot going on in here. This is going to be a real easy one to clean. Okay, so this went in this orientation. So I'm going to make a mark on my heat spreader so I know a reference, so I know where it lines up with the triangle. And I see a dot here, and I see a dot there, a dot there, and a dot there, and nothing on that side. So I'm going to make a little note on there so that it lines up correctly. Anyway, I'm going to go through now and use a what is it? It's called an orange stick, and I'm going to clean all of the silicone off here, and I'm going to clean all of the silicone and the compound off of that. Put everything, get everything ready for liquid metal, and we'll come back. We have the heat spreader cleaned off. All of the thermal compound and silicone has been removed. Same with the die and the PC board. Everything has been cleaned off. The die is perfect. What I use on these is I use a lens cleaner with alcohol to give it a final clean. Now I'm going to go ahead and mark out on my IHS where my liquid metal has to go. Then I'm going to apply that and apply it to this. I'm going to apply a very, very tiny, thin line, little tiny smear of silicone around the edge of this, just enough to adhere it. There's an issue with putting on too much silicone because then it'll create a space on this between the IHS and the die, which we don't want. We want it really, really flat. I was going to lap the IHS, but I'm not going to. I'm going to leave it factory because the actual heat sink here is not flat. It would be absolutely pointless to make this mirror flat when this is all kinds of lumpy. So I'm going to leave it alone and put my graphite directly onto it and onto this. If I don't get the proper cooling on this that I'd like to achieve, then I'm going to remove it, remove the graphite, and put thermal grizzly back on it. But we'll see what happens. All right, next. I also forgot to mention this again, because it's my nature to be a little bit on the overkill side. You had a couple of contact points here under the hood that are not outside of where the IHS mounts. So what I do is I cover that with some acrylic lacquer material that is specifically made for coating components on circuit boards. It's typically used in radio controlled planes and boats and drones and that sort of thing to keep moisture off of electrical contact, so it's perfectly safe for the PC board. It's like some people use nail polish. This is just a nail polish essentially that is designed specifically for this. So these points have been coated twice, so they're set so that because liquid metal is conductive, if some did spill over here, I don't know what the consequences would be, and I'm certainly not going to take that chance. So that has been coated, just so you know. Now we've got the conductinaut on the die. We've got heat spreader ready to go. We've got silicone on it. I've got it registered so that this is the correct orientation. This corner goes in there. I'm going to lay it in here gently. That's right where it goes. And I'm going to find the 2 screws I had for this thing. There we go. This is backed up. In there. It really only goes in one way. This is pretty goof proof. So what we want to do is just make sure that everything is flat, our guide is flat on our base, and we snug it down pretty well. And then I'm going to add pressure on the center cap so that my silicone will adhere to the PC board. And I'm going to let it sit. I'm going to let this sit overnight, and then tomorrow we'll put it in place and do some temperature testing. A quick recap of what we did yesterday. Yesterday we took the laptop apart. We removed the battery. We removed the CPU cooler. We removed the CPU. We delidded it. We used thermal grizzly conductanot to join the die to the IHS. I used some Permatex Ultra Black sealant to seal the IHS to the PC board. I'm going to open this up now. Reduce my pressure. Okay, let's see what we did. There's our CPU. All right, upon close inspection, it's clean. There is an absolute little micro bead of black silicone on the very edge there, showing me that I've sealed this all the way around. One of the precautions in delidding, and I've done a few of these, is not to put too much silicone on the heat spreader when you're putting it on, because that will create a big space between the die and the IHS, and won't give you the kind of thermal transfer that you're looking for. So by keeping your silicone really thin, and I also let it sit overnight or for at least 4 or 5 hours. I want this thing locked in. So once it's locked in, we're done. This should work pretty well. Let's see, did I miss anything? I don't think so. I'm also using, I use Zeiss alcohol lens cleaners a lot. I buy them by the brick at Walmart. They're great for cleaning surfaces and prepping them. Also, another thing, when you look at your rocket, it comes with a little what they call an orange stick. It's a manicure stick, and you can buy a dozen of these for like $1 at Walmart, and they're really great. They've got a round pointed end and a knife edge, and they're really good for cleaning that silicone off. So we are just about ready to apply the graphite pad to our CPU and put it back in the motherboard and mount our heat sink. I'm going to try and make this as quick and painless as possible. I do want to mention again, this is not sponsored by anybody. I'm doing this so that my end user will have a more practical laptop for his purposes of imaging. He wants something in the field that he can run full tilt all day long and not have to worry about it. My big concern with this, it's a beautiful machine, is thermal throttling. And I don't know what environments he's going to be in. He travels in the field. He could be out in a desert somewhere. He could be in a museum in Europe. It doesn't, you don't know. So I also want to thank Jeff and Wesley at ProStar once again. I have purchased from Sager, I have purchased from Origin, and I choose to purchase from ProStar. Again, it's not a commercial for you guys, but your service is outrageous. I mean, I've had, we've had some stuff going on overseas, and you handled it like perfect. I mean, I couldn't be happier. Also, the equipment you sell is absolutely top of the line. So, that being said, it's time to put everything together. So I'm going to take my little dust cover off my pins here. That's the other thing. When you're playing around with this thing, you have to be really careful not to let anything touch those pins, knock them out of alignment, get in there, no dirt, no oil, no dust. I inspect everything twice before I put it in, just to make sure that I'm doing the right thing here. I'm also going to get myself a little stick here that I can use to ease my CPU in, because I just don't like it thumping on the pins. So here's my alignment mark here and here. So my CPU has to go in here. I'm going to set it in right there, and I'm going to put this underneath it, and I'm going to ease it down so it doesn't bang in there. Okay, it's set. I'm going to close the cover and lock it in place. We're done. So now we can start looking at our thermals. So I'm going to take a thermal pad. Here we go. Boy, is this easy, right? Orient it that way. It's square, so it shouldn't matter. There we go. Okay. If this works, man, this is so nice compared to playing with grease. Okay, so now I want to put my fan in position. Before I do this, actually, I've gone ahead and let me clean some. Let me do something. Let me do something right. I just want to make sure that there's no grease from, I mean, I'm wearing gloves and I don't touch this with my bare fingers, so it's not likely that we're going to get any grease on it. But I still would like to just go over the surface real briefly. Make sure it's clean and dry and residue free. Okay. And pop that on there. Wow, this thing really slides around. You got to be kind of careful as to where you have it. You want to make sure it lines up on your heat spreader. This is a 30 millimeter patch. It covers it really well. On an X299, you'd have to use the 40 millimeter. But now, I'll get a screwdriver. Let me line this thing up. Okay. I back my screws out just to make sure that I'm in the hole. And now I've got 1, 2, 3, 4. They're all caught. I'm going to go back to 1. And then 2. And then 3. And then 4, and then 1, and 2, and 3, and 4. Okay, now I'm going to put my fan back in. The quality of the connections in this laptop, the way things are routed, I mean, it was almost like it was designed to be worked on. It's just beautiful. It is really comfortable to work on. You can see that somebody really put some time into engineering this thing correctly. So now I just want to make sure that before I put this thing together, I've got everything tightened down. I'm just going to triple check. I'm not getting ridiculous on this thing. There's no need to. It's more important that you use the proper tools for this, the right size screwdriver bit. Now I'm going to connect my fan wire. And equally important, on this wire, on anything like this, any one of these connectors, you do not want to pull the wire. You want to pull the connector if whenever possible. So same thing when putting them in. You place it in and you press on that connector. It's now in place. It's locked in. It's routed correctly. We're done. The next thing we're going to have to do is put the battery in. So let's get our battery up. So our battery goes in this way. The little tabs go in the front. And you can gently place it down in the tangs. It takes 4 screws. We'll speed this up Looking at my tabs here. Perfect. Okay. Okay. Okay, this is nuts. I just did a screen grab on what I've got going on here. This is IDA 64, and I'm running it at both CPU and FPU, and I ran this for a little over 14 minutes. My highest temp was 67 degrees. When I first started this out of the box, this thing thermal throttled in less than 5 seconds, and I was up into triple digits. I had to shut it down. This is a phenomenal difference. So far, so good. I'm seeing on average a 10 to 12 degree difference on everything from delidding and another 10 degrees from undervolting. I'm going to put everything together in a PDF and go through it in a minute.